Hi, my name is Batul Agha, and our group's final project is on mechanical energy processes. Mechanical energy processes is essentially the energy of motion and the energy of objects that move. So, there are three main types of mechanical energy processes, which our group has so far researched. One of the types is ultrasonic machining. The second type is a process using water jets. So there are two types of processes using water jets. One is water jet cutting, and the other is abrasive water jet cutting. The third type of mechanical energy processes is a non-traditional abrasive process, which consists of abrasive jet machining and abrasive flow machining.
Hi, my name is Alex Padron. I'll be giving a project update for ME380, specifically non-traditional machining practices that require mechanical energy, and more specifically on ultrasonic machining. Ultrasonic machining is essentially a material removal process or a surface finishing process, which is typically consists of a tool called a sonotrode that utilizes high frequency, low amplitude vibrations uh, placed above and in between a work slurry, which is a mixture of water and fine abrasive particles. These abrasive particles essentially erode the surface material, which leaves for removing small defects on the material surface. One type of ultrasonic machine is the Ultrasonic 50 by DMG Mori. This is a high-end combined USM and milling machine, which is used primarily for semiconductors, camera housings, and engine blocks. It's essentially used when you want to either make small cuts, typically non-round holes on curved surfaces, or to remove minor defects in the material surface.
Water jet cutting uses a fine, high pressure and velocity stream of water impacting the material surface perpendicularly. In water jet cutting, the fluids are preferred to be polymer solution because it tends to form a coherent stream. As as the diagram shows, the fluid goes through the tube and is ejected by the nozzle directly to the surface in order to make sure the pressure approaches maximum. There are several parameters that should be considered. The standoff distance between the nozzle and the surface is expected to be small to minimize the dispersion, but don't contact the surface. Change the nozzle opening diameter and the pressure of the fluid according to what material it is and how thick it is. These two parameters decide the rate of cutting feed, typically from 5 to more than 500 millimeters per second. Water jet cutting is usually automated using computer numerical control or industrial robots to control the nozzle unit along the trajectory we desire.
Hi, my name is Mark, and another non-traditional machining mechanical energy process I would like to talk about is abrasive flow machining, short for AFM, and it's the precision finishing technology. So, it's an interior finishing process that has an abrasive laminate fluid, which is forced inside the chamber that needs to be cleaned and causes erosion, which removes the hard surfaces of the material, and it basically polishes the inside of that material. From the left hand picture is the setup of the abrasive flow machining, and then here's the process, and then here's the output of the material that was put inside of the machine. And as you can see, the interior of this material is smoother than the right hand side, which is has a hard surface.
Hello everyone, my name is Benjamin Viscondi and I'll be going over the abrasive jet machining process for our project. This process is also known as microblasting and is somewhat like water jet cutting, which was previously discussed. However, with this process, rather than using a liquid solution, fine particles commonly known as abrasives are used. These abrasives are small spheres with a diameter of about 0.001 inches or 0.025 millimeters. Some example of these include aluminum oxide, iron oxide, silicon carbide, and powdered iron. These minerals are introduced into a mixing chamber where it is combined with high pressure air obtained from a compressor. A vibrating bottom at the base will help the chamber to mix the air and particles thoroughly. Then once mixed, the two will be transported via a line to a nozzle. And then in order to create the blasting process, Bernoulli's formula will have to be used. This means that as the pressure decreases when leaving the nozzle, the velocity of the mixture will have to drastically increase. This high velocity abrasive will then hit the work material and begin to blast away any unwanted pieces or material through friction. Once this process is finished, the manufacturer will be left with a smooth finished piece.
I'm now going to be discussing the advantages and disadvantages of different applications of mechanical energy processes. For ultrasonic machining, some of the advantages is that it has high precision, which means that it has the highest surface finish available than other processes. It also has a low cost because it uses minimal energy, and high speeds because the high metal speeds lead to high production rates. Some of the disadvantages is that it can't be used on brittle materials. It has a cutting tool that has a quick wearing time, and it may damage surfaces and make them look uneven. In terms of water jet cutting, some of the advantages is that it is considered green tech because it doesn't create any hazardous waste. It also cuts almost any material and has extremely high accuracy. Some of the disadvantages is that it has slower cutting time, meaning lower production rates. Its regular orifice failure slows production and wastes time. It also has a high starting cost. In terms of abrasive flow machining, some of the advantages is that it has the ability to control specific output using different grit sizes and types of media. It also has a quick setup and quick change tooling and is fully automated system capabilities. Some of the disadvantages is that it has surface integrity with low surface finish and high machining times. For abrasive jet machining, some of the advantages is that it is suitable for non-conductive brittle materials, has low capital investment, and the process is independent of thermal or electrical properties. Some of the disadvantages is that it is not suitable for soft and ductile materials. Abrasives are not reusable for this application, which means the collection and disposal of the abrasives is problematic, and it has a limited nozzle life.